Hello there. This is the project which shows how OpenCV can solve real-life problem of industrial application. Hi, myself Ashish Patel and I am industrial automation engineer and maker by my hobby. At my workplace, we face one problem which is quite novel and we didn't find any solution for that. I then tried to solve this problem using OpenCV and guess what? We succeeded. To understand this project, first let me explain the process. This is the belt conveyor which is used to shift bulk cargo like coal or gypsum. Speed of this conveyor is 4.2 meter per second, which is quite high. It is currently moving cargo. There is almost 12 similar conveyor in the system. The big orange object above the conveyor is a magnet. This is the IP camera. Image data of this camera is processed using OpenCV and alarm is generated. Now here are some metal objects which are detected by object detection system and removed to protect the belt conveyor from being damaged. Here you can see how cargo is transferred from one conveyor to another conveyor using transfer chutes. This cargo is received from mining and shipping industry, so often having metal parts in it. These metal parts can damage the belt, so big electromagnets are used to segregate the metal parts from the cargo. Here you can see how the belt got damaged. Sometimes metal part stuck between magnet and belt. Belt speed is quite high, so metal part act like a knife and cut the belt part. Belt is very costly and its repair took almost 24 to 30 hours, which cost a lot to my company. This is the idea I came up with. I decided to install camera in front of the belt and a magnet. One unique colored plate is then installed at opposite side of the camera. Finally, using OpenCV, I can monitor the space between magnet and belt. If something came between magnet and belt, alarm can be generated in SCADA to stop the conveyor. This is how final solution works. Using masking function, contours of yellow plate generated. Area of yellow plate is then calculated using height and width reading of contours. By monitoring area and width of the contour, we can detect abnormal condition. As shown in this image, area and width reading decrease if something stuck between magnet and belt. Area and width reading is then transferred to SCADA for alarm generation. 4 scroll bars are provided to create ROI. Green square is showing ROI on original frame. Here you can see how I have set ROI using these scroll bars. There is problem with this approach because yellow plate is not perfectly rectangle in camera frame and camera may be rotated during cleaning operation. This causes improper area calculation of yellow plate during contour processing. To solve this problem, I have used perspective wrapping feature of OpenCV. 8 scroll bars are provided as you can see in this video. Each corner of yellow plate are selected precisely using these 8 scroll bars. Selected image is then converted into proper rectangle using perspective wrapping function of OpenCV. This provides proper width and area measurement of contour which can further use to generate proper alarms. Once ROI is generated, next step is to provide mask on ROI. To provide mask on image, I have converted RGB image into HSB using OpenCV function. Then 8 scroll bars are provided to find proper masking value. I have followed trial and error method to get accurate values of HSB masking. Once I get satisfied with result, I have noted down each HSB mean and max value from scroll bar and then I have hard coded each value in my final code. Actually, I have tried with blue, green, yellow and white color plate initially, and by comparing these 3 or 4 plates, what I observe is yellow color perform very well with masking. So I have finalized yellow color for my final implementation. This is how data is transferred. Area and width data is converted into JSON packet and sent to MQTT server. SCADA which we used is OPC protocol support only. So CAP server is used as a data gateway. It reads data from MQTT and forward to SCADA using OPC protocol. Final validation of area and width reading is carried out in WinCC SCADA for alarm generation. This is the live demonstration of the project. The gray screen you are seeing here is the SCADA and the red lines are running conveyor. At the right bottom corner, I have put the live camera feed which is installed in front of the magnet. Now whenever any object inserted in between the belt and a magnet, the live feed screen is overlaid on the WinCC screen, so the control room operator can immediately get notified about something is going wrong or not. Apart from that, one alarm text which is showing belt trip is also pop up on the screen. Now as soon as the object is removed, these both conditions are removed. So this is how the project is working. Way forward for this project is to implement AI based solution using YOLO. I am currently working on it. So that's all about the project. Thanks for watching this and give me comment in the comment section.